Page 193, number 18. The directions say to graph the function in a viewing window that shows all of its extrema and x-intercepts. Describe the end behavior using limits. Okay, so I didn't give you a lot of space for this one. I apologize for that. But here we have a polynomial, and the best thing to do is to put it in your graphing calculator and see what window works best. So I went ahead and put it in the graphing calculator, and I just used the standard viewing window, and I can see my x scale is fine here. I can see all the x-intercepts. It's a third degree polynomial. I have 3 roots, so I see those. What I do notice is that the very top of the one local max and the bottom of the one local min is off the screen, so I want to change my window settings a little bit. So I'm going to try like from -20 to 20, because it doesn't seem like I'm that far away. And I think I'll change my scale a little bit. Oh, that's the x's. I don't want to change those. Those were fine. So -10 to 10. And then the y scale is the one I want to change. -20 to 20. And that is what I'll count by 5s. So go ahead and look at that. And now I can see I am going to have a very nice graph. I can see all the behavior of it, and I can see the end behavior as well. So let's go ahead and graph that. So what we're going to have is, whoops, let's make this a little bigger. What we're going to have is a scale counting by 5s on the y, 5, 10, 15, 20. So -5, -10, 15, -20. So counting by 1s on the x's. And so we have a root at 4. So let me use those different color. We have a root at -1. And you can see those 2 roots here and here. Now that means the other root is going to be 3/2 when I solve the first, if I set this equal to 0 and solve the first parenthesis for x. So that's like right here. And then what I saw was the function looks like this. And the bottom came down here like that, turned around, went up, and came down like that. Okay, so I can see that to the left we're going to infinity, and to the right we're going to -infinity. So my limits will look like this. The limit as x approaches -infinity of f of x is going to be infinity. That's my left-hand behavior. And my limit as x approaches positive infinity of f of x is going to -infinity. That's my right-hand behavior.